Welcome.
Yeah, thank you very much. It's great to be here today. So, as you say, my name's Thomas Delgado. I'm the CEO of Pollution Solution. And I'm the inventor behind our technology, Roadvent. So here to speak to you today about what it is that we do and why we do it. So we tackle air pollution. And why is that important? Well, air pollution affects us all in some which way or another and is inextricably linked to the length of life that we live. So depending on where you work and obviously where you live, that can affect the length of your life. Air pollution is now considered to be the world's largest environmental health threat by the World Health Organization. And the reason it's such a prevalent issue is that it affects every single organ and every single cell in the body. It's actually been found to cross the blood-brain barrier and has even been found in unborn children. So from heart and lung disease to various other obviously terrible issues that end up being fatal for many people, there's a huge reason to solve this problem sooner rather than later. It costs the UK economy alone £20 billion a year, which is absolutely staggering. The majority of that cost is actually a financial burden borne by the NHS, usually trying to resolve things like asthma, but it's also contributed to by a loss of productivity, so people having sick days. That equates to, in numerical terms, 3 million work days a year in the UK alone, and a staggering 1.2 billion days a year globally. So what is Roadvent and why has this product come around? Well, about 9 years ago, I was walking down the road and I saw some vehicles queuing and pollution leaving the back of those cars. At which point I thought there must be a way we can engineer a solution to this problem. And we then went through a phase of 8.5 years of R&D, believe it or not, and launched the business about 6.5 months ago. So Roadvent consists of 2 linear slot drains that we installed into the running carriageway, as you can see here in the image. And they're connected at the roadside to a cabinet, which has a fan and various layers of filtration. This is a roadway-approved infrastructure solution and is rated to 90-ton weight limit, so it can effectively go on any road as a new solution or a retrofit. We have patent-granted status in 21 countries, and as I mentioned earlier, this is about 8 years' worth of R&D that's gone into this. The most important thing is the efficacy, and this is what we focus on, so reducing emissions exposure at the roadside. And the long story short is that, on average, independent scientific testing shows there's a 91% reduction. And this graph here gives you a brief snapshot of that. But if you're able to play the video, you'll see it in action. So, as you can see, the linear slot drains are installed in the carriageway. Cars can drive over them. Cyclists can go over there. They're completely pram, cycle and pedestrian friendly. And here we're using a smoke machine to visualize exactly what's going on, because obviously air pollution is invisible, so this does a great job at showing exactly what's happening. It's effective at capturing pollution both moving and static vehicles. And this is the efficacy in real time. So we're measuring NOx here, NO and NO2, as you can see on the graph. And in real time, on the top half of the screen, fairly self-explanatory, the system is turned off, and the bottom half of the screen, the system is turned on. And of course, there's massive average reductions, but it's also about mitigating these spikes that we so often see. So if, for example, a parent is walking a child to school in a pram, they could be subjected to a spike if they walk past at that time. So use cases. As I said, we launched about 6.5 months ago. We're now in talks with 28 local authorities in the UK about installing hotspots in air quality management areas. These are legally binding areas that councils have to legally do something about. However, the shocking truth is that some of these have been around for over 20 years. And of course, every year in the UK alone, there's 50,000 people dying as a result of exposure to air pollution. We now have an installation underway with the NHS, which we will be announcing shortly, probably in about 3 months' time. And that is tackling emissions which leave ambulances and stopping them from going into the A&E department, which is obviously affecting vulnerable patients, but of course staff. And there's many other use cases that we've been approached about, including next to cycling lanes to encourage active travel, and of course at bus stops and street canyons. Street canyons are really about architecture. This is where we have tall buildings at either side of the road, and unfortunately the pollution naturally builds up from the cars because it's not being diluted. So we can tackle that. And then just finally, drive-through restaurants. This is an acute problem, a global problem. So workers, low-paid workers, are being subjected constantly throughout the day, 8-9 hours, to pollution from customers' cars, which we feel is not acceptable. And of course, in the UK, we have health and safety legislation that should be protecting these people. So the benefits of reducing human exposure, hopefully it's fairly obvious. With the public sector, slightly different to the private, but it's all about achieving compliance with air quality targets, improving public health, reducing the financial burden. The way we look at this, prevention is better than cure, and obviously it's a lot cheaper. Reducing work and school days loss the effects of air pollution, and encouraging modal shifts. If people are going to walk and cycle, we have to protect them from road-based pollution. Private sector is slightly different. Employers have a legal duty anyway to protect staff. Ensuring compliance with health and safety law is key. And in the USA, things are starting to change. So class action lawsuits are starting to come through, where employees are complaining that they've been subjected to air pollution, now suffering from ailments similar to asbestos was many, many years ago. So again, class action lawsuits cost a lot more than solving the problem up front. So if you know of any use cases where this technology would be of use, please get in touch with us. I am presenting and we are exhibiting here at Stand G2, and we'd love to hear from you. So thanks very much.
Thank you, Thomas. Thank you for the presentation. Are there any questions from the audience? If you have one, raise your hand. There you go. One question over there.
Hi, nice technology. I was just wondering, with the graphs where you're showing the clean air, where were you measuring that from? And kind of a follow-up to that, what does your exhaust look like?
Yeah, sure.
Are you removing NOx and particulates?
We are. Yeah, it's a great question.
And then what do you do with that?
Sure. So what might not be clear from the videos is that there's a cabinet above ground at the roadside, and that houses the fan, but also the filtration. So in terms, to answer your question, we have a 99.95% removal rate of particulate matter down to 0.1 micron. So we're utilizing ESP technology, so electrostatic precipitation, as well as HEPA, and that rating is called MERV14. So what that means is that's almost medical grade particulate matter removal. And of course, PM comes off EVs as well as fossil fuel cars. In terms of NOx, we are removing the NOx from the airflow, so we're using impregnated activated carbon to do that. And that works slightly differently to the original HEPA filter, but that's about dwell time. So we've got a really heavy-duty block of carbon effectively at the side of the road. To answer your other question, where were we measuring it? So we've measured at various different points. All of the stats show at least an 80% plus improvement. So just to give you a flavour of what that looks like, at the roadside at different distances, up to 1 metre away, 2 metres away as well we've tested. The metre high is really focusing on children in prams, as I said. We've also measured at the height of a server at the drive-through hatch, and we've also looked at in-vehicle exposure. So this is about protecting people in cars as well, and the in-vehicle exposure is reduced by over 84%. So even if you drive an electric vehicle, you might still smell and breathe emissions in from other cars. So hopefully that answers your question.
Any other questions? Okay, I have one. So you focus on hotspots because, well, it's probably a very good idea to reduce infrastructure costs and a quicker implementation. Do you have the numbers, at least the order of dimension, of how much of the air pollution coming from roads is actually at the hotspots and how much is not there or in other areas?
Yeah, it's a really good question. So cars are generally quite efficient when they're moving, and we also have this distortion effect of basically pushing emissions around and upwards and into the atmosphere. So trying to tackle pollution from moving cars is very, very difficult. But what we found is, by studying a lot of air quality maps, is that when vehicles are slowing down, static or moving very slowly, so stop-start, we often have people nearby. So this could be traffic lights, zebra crossings, as you can see, schools, nurseries, etc. So that's really why our focus is there. And it's also about efficacy, having that massive impact. But certainly, to answer your question, tackling this at the source as we do, at the hotspots, will reduce the overall average. And that's what we're speaking to councils about, because they're focused on, of course, the entire borough or community there. So tackling at the source, we remove a great deal of that and reduce the overall averages.
That makes a lot of sense. I wonder, just as a follow-up question, if you, like, what realistic solutions are out there for that extra step, so they're not hotspot?
Yeah, so we don't have the silver bullet. We're not claiming to have the silver bullet. This is about doing as much as we physically can now to protect people now and stop the cost and, of course, deaths. Yeah, I think this has to be a multifaceted approach with various solutions for different problems. I think as humans, we look to try and find one problem with one solution, and that's just not the case. And that's obviously why we're all here, to look at different solutions. But again, we have our expertise for certain things, and we can do a great deal of good for the community. So,
Very good. One question.
Hi, do you think this solution can be used for factory emissions?
sorry, I can't.
Factory emissions in the interim until they can be,
Yeah, so
net
there's
zero?
already companies out there that specialize in that. Our patent that we have in 21 countries is really focused on road-based emissions. And we've been approached since we launched about a whole host of amazing situations and weird and wonderful questions, from ferries to factory emissions and so on and so forth. But the long story short is that's not really our focus. There are a lot of very good technologies out there now, and we certainly encourage any piece of technology that can improve air quality. So.
Great presentation. Thanks.
Thank you.
Thanks for that. My question is, you mentioned the fan above ground. How many meters of vents or track does that get you?
Yeah, so we sell this in 20-meter modules, which is generally about 5 or 6 queuing cars, and also, just by coincidence, really covers both the serving hatches at fast food restaurants. So what we mean is we sell 20 meters per cabinet, but this is modular, so we can install as many as required. And we've actually had a request for the drive-through industry in the USA, and out there the drive-throughs are massive. So you're looking at 100 meters and 3 lanes of that, which is fine, we can tackle it, but it's 20-meter modules and 1 fan.
Any other questions? We still have some time. There we go. Sorry.
Yeah, what happens to the particles once you've captured, and who deals with the maintenance thereafter?
Yeah, great question. So we've actually partnered with many companies that can offer us a turnkey solution in terms of maintenance, because that's key. If you don't maintain the filters, you won't get the efficacy. So a company called Purified Air, they've been established for 38 years. They've got a team of 400 engineers already running around the UK, maintaining similar HVAC systems for buildings mainly, and also the fast food industry to stop the cooking extraction. So to answer your question, the bulk of the filtration, the PM, for example, goes through an electrostatic precipitator. When we maintain that, what we mean is an engineer attends, and it takes about 10 minutes. They basically seal up the cells, the ESP cells, in a bag, so they're contained, and new ones are placed in. However, those cells are then taken away and washed with steam, and then put back into like a circular economy, if that makes sense. So they go back into the maintenance regime. So they are reused. That waste, obviously, that's the pollution, is captured and disposed of safely. That's the best that can be done, unfortunately, at the minute. We can look at recycling, and there are brands who are turning that into jewellery and all sorts of other things, which is very interesting, and we are looking at that. But our main focus at the minute is making sure that humans don't inhale that for the meantime. And it's, of course, safely disposed of anyway. So
We still have time for one last question. Otherwise, we can wrap it up. All right. Thank you very much, Thomas, for the presentation. Yes.